Welcome, everybody. Welcome to the Large Language Model Task Force. My name is Edie Lush. I'll be the facilitator for this session. Absolutely delighted to be here with you guys all here. We are going to be hearing from three experts, and I've had the pleasure of speaking to all of them already. I can tell you, you are in for a treat. These guys are the experts. We're going to discuss some of the critical challenges and opportunities around large language models. Our first guest we're going to get started with joins us from Huawei. He is an expert in cloud computing and AI technologies. Dr. Zhu envisions a future where AI is an integral part of every single industry, making businesses more efficient and innovative. Huawei, we know, is building many large models, which they call Pangu models, everything from finance to weather forecasting. One particular area of interest is using AI to mitigate the effects of climate change, especially here in the Middle East. Their Pangu weather model is looking to understand and predict weather patterns by analyzing enormous amounts of data. We'll hear more about that. It was in the scientific journal Nature last year. So we're going to get him up on stage right now on keeping LLMs up to date, the challenge of maintaining current and relevant models. Welcome.
Thank you so much for your kind words. Hello, everyone. My name is Dr. Zhu. It's an honor to be here to have this opportunity to discuss with you about LLM and how we can keep the LLM up to date. Okay. So actually, this is a very important and a little bit technical but a very meaningful topic because now LLM is already driving AI into the new heights. We know we can train an AI model from a lot of data set. But for large language models, it requires a huge amount of data set, and then the model parameters is enormous. Like we're talking about hundreds of billions of parameters, or even larger, right? So how can we learn so much knowledge from the data set? And also, more importantly, how can we keep the model up to date? So that is the main topic, because if we're going to really use the models in our real applications, we need to make sure that the model can answer the questions up to date, rather than giving the out-of-date answers to our users. So that is the very important topic here. So today, we're going to show that the importance of LLM knowledge update. We summarized a few points. The first is, of course, to improve the performance of the LLM. For example, improving the accuracy of answering the questions, improving the relevance of the answer to the question from the users, and so on. The second is adapting to societal changes, because as you know, a lot of things changed for our society, our history, and so on. So we need to update the knowledge base so that the model will reflect this. This is very important. And also maintain ethical standards and enhancing the user trust. This means, for example, in every country, in every society, right, we have our values. It's about cultural or societal or political values. We need to keep these very important aspects up to date. So that is the importance of keeping the LLM or any large models essentially up to date.
Hi. Welcome, right over there.
But we are facing several challenges about keeping the LLM up to date. So here we summarized a few points. First, as we know that large models, they are trained on a huge data set, right, the training data. So if we're going to train the whole model again, then that is very time-consuming and very expensive. As you know, for example, if I'm going to train a model of 100 billion parameters, that will usually take about more than thousands of GPU cards and train for more than 3 to 5 months. We cannot do that every day. We just train it and then use it. So if we train the whole model from scratch, that is too expensive. It's not practical, right? And also, the data itself may be biased. We know that the data distribution is not always balanced. That is the problem. And then we need to solve this by continuously improve the quality of the data set so that the model can learn from this data set and keep the answer more balanced and more accurate. So if we're going to keep the models up to date, we need to solve these problems. So here I listed several technologies. The one technology is called fine-tuning. So it's essentially I have already trained the foundation model, and then I added some new data set, and then we can just fine-tune the model. It's just the incremental training. So it does not require to use all the GPU cards and not to train for 5 months, right? So fine-tuning is just a little bit of data set and a little bit of training. So that is one way. It's called fine-tuning. Another one is called a retrieval-based method. It's not like I'm going to ask the model to learn everything and memorize it in the model parameters. But instead, every time you ask me a question, the model will retrieve from the internet or retrieve from our company's internal database and get the latest document or latest data, and then ask the model to summarize it so that it gives the final and accurate result to the user. It's just like a librarian, right? So every time you ask a question, I will check the textbook first and then give you the answer, right? So in that way, I can always add in a new book. I can add in a new PDF file or Word document, and then I can retrieve and get the content and then answer it. So that is a retrieval-based methods. And then we also have other techniques, for example, continuous learning or knowledge editing. So these are still techniques we are exploring. It's not that mature. For example, continuous learning is like a student. You will keep learning from one subject to another subject, from grade 1 to grade 2 and grade 3. In the meanwhile, you will keep the historical knowledge still stored in the models, but then at the same time, you will learn new knowledge. Knowledge editing is just like you directly edit the models. For example, you added some facts. For example, Pluto. Previously, we think it's, for example, we say Pluto is a planet. But recently, after some meetings, the internet community they, decided it does not meet the standards. Okay, the fact changed. Then we directly added this knowledge and then reflected it in the model. It's not like directly train the model again. It just directly added this specific fact so that the model updates this specific knowledge. But you can see I also listed some dimensions. So all these technologies, they may have different side effects, or whether they support batch updates or not, whether it is persistent in the model parameters. So it all has different features. And also, we can see that the application maturity is different. Fine-tuning and retrieval-based is relatively mature, and we already use it in many industry applications. But continuous learning and knowledge editing, they are relatively in the academic research stage. Okay. I also give another example. We all know that ChatGPT is one of the typical LLM, right? So how does ChatGPT update itself? We can see that through all these years, they publish different versions, GPT-2, GPT-3, GPT-4, and 4.0, and so on. So these big versions, they train it from scratch. It's a new model with larger parameters. They need to train it from scratch. It's a completely retraining process. It's very expensive. But then we can see that this model, they have this specific release date, and also the training data has a specific cutoff date. For example, GPT-3, right? The cutoff date is June 2020. So if you ask any question after this date, it will directly give you the answer that I don't have that specific knowledge, right? So this is how they handle this problem. And also, these models, they are continuously trained. This also use a fine-tuning capability, and also they released this to our end users. So it allows the users to add in some specific domain data or new data, and then fine-tune the GPT models a little bit so that it can answer specific questions from your company, from your sector, and so on. So this is just one example in the industry. And also here I will quickly introduce some technologies. This one is called reinforcement learning from human feedback. So this technology is already used in ChatGPT. So it's essentially using the reinforcement learning to improve the model performance. For example, I already have this large model. It can understand Arabic, English, and other language, for example. But the answer from the models may not meet the human criteria. For example, if I ask a human a question, the human may give me a very direct, concise, and appropriate answer, right? But for the large language model, sometimes it may not be able to directly achieve that performance. So how can we ask the model to behave or answer questions just like a human being? So to do that, we train another reward model, and then this reward model will give the reward or score about the answer the model outputs. For example, this answer is better than that answer. So this reward model, they can tell whether this answer is appropriate or it is suitable for human beings, right? And then we use this model to improve the large model itself. In this way, it's the reinforcement learning. The large model's output will be closer and closer to the human's expectation. So this is a very important technology that we're going to update our large models so that it meets the human standards. Another fine-tuning technology is called low-rank adaptation, or LoRa. So as we can see here, if we input the data into the pre-trained weights and output it, we need to change the parameters of the whole large models. Every parameter in the large model is changed. But there is another technology called LoRa. It's like, I don't need to change the whole model. It's like hundreds of billions of parameters, right? But instead, I will use another low rank or smaller model. It's like A and B over there. I just update this smaller model and then add this model's parameters to the pre-trained models. So this is just a shortcut, or it's like a trick. I don't need to update the whole thing. Instead, I update a small portion and then add this portion back to the larger models. So this is a very practical fine-tuning technology. It saves us from training the whole model from scratch. Okay. I would like to introduce another technology. It's called the retrieval augmented generation. So you know, large language model is a generative model. It can generate the answer, generate email answers, or generate code, right, or generate a new image. But how can we always use up-to-date data? So that is a retrieval augmented generation. So this is the pipeline. For example, the user has a query, and then this query is not fed into the large models. So instead, I will put this query first go through the knowledge base. It's just like a Google search. I will search the internet, I will search the internal document base, and then I will first get a few relevant documents. So it's from the huge data set. I will only get, for example, top 10. Let's say top 10 relevant documents. And then I will input these relevant documents into the large model. So then this large model can know, okay, I can get the answer from this top 10 documents, right? So this document can update very quickly. For example, I have a new product. It's a new PDF file. I just add it to the database. Or there is new information on the internet, right? For example, the weather or the news. Then I can directly get that knowledge and then feed that into the large model. And the large model is able to understand this content and then give the user a very direct answer. So this is called retrieval augmented generation, or RAG. So this is already successfully utilized in a lot of AI assistant inside companies or different sectors. Okay, it's a RAG method, retrieval-based method. So here is a summary. So we can see that over the time, we can already develop different technologies. For example, knowledge editing, continuous learning, or retrieval-based method. For example, there is a lot of facts or knowledge updated. For example, who is the president, and then who won the World Cup in Qatar, or the latest news. Different knowledge have different ways of updating the knowledge, but they may have some side effects, or their cost it differs dramatically. So how can we choose the correct way to use in our own scenario? So we may see that it depends on how you update your data and what kind of data is updated and what is your requirement or how much cost you can accept, right? It depends really on your scenario. So for now, retrieval-based method is already widely used in many scenarios, in search engines, in our internal AI assistant chatbots. And then fine-tuning is already widely used in many industrial scenarios. For example, in Huawei, we develop our own large models. It supports NLP, CV, and so on. Support many different languages, including Arabic, Chinese, English, and so on. But this foundation model cannot answer all the questions in the vertical industries, right? For the banks, for the government, and so on. Because a lot of banks, they don't put their internal documents on the internet, right? It's not publicly available. OpenAI or any company, they cannot directly access the internal or secret documents inside the company. It's just not available. So a practical way of doing that is these vertical companies, they just fine-tune the foundation model, just add in their private data, and then fine-tune a little bit so that this model is able to understand the finance terminologies, a lot of jargons, a lot of industry know-how, right? So this is also a very practical way to apply large models in different industries for finance, for government, for oil and gas, and so on. So fine-tuning is a relatively mature technology. It's already widely used in different industries. And also in the academia, we are also exploring different ways of, for example, continuous learning and knowledge editing. Hopefully, in the future, if we can have some breakthrough in the model explainability, we can see how this fact or how this answer is wrong and which parameter leads to this wrong answer. And we can have this very precise edit of the model parameters. So just to change the parameter a little bit, and then the answer is correct. So hopefully in the future, that technology will get more mature, so we can have a more direct and easy ways to keep the model's content update. Yeah. So this is just a summary, but I believe the large model area is evolving very fast. A lot of new models, new technologies, new systems is emerging every day. So this is a faster evolving area. Hopefully, we'll have more breakthrough in the future, and we would like to work together with us and to have more conversations like this in the future. So thank you all very much. Thank you. Thank you. Thank you very much. Thank you.
Thank you so much. Come and have a seat. So
Thank you.
you, the audience, now have the opportunity to grill Dr. Xu. Anything you ever wanted to know about Huawei's large language models.
Please. Okay.
So I've got a few questions, and I've got a few ringers in the audience, our future speakers who are going to come up. If you've got a question, do raise your hand, but I'd love to come to anyone who does. And if you see somebody behind me that I haven't seen, just let me know. One thing I do want to know, I'd love to hear a little bit more about the Penghu weather model. It was published in the Scientific Journal last year.
Yes.
Really interesting tool, predicting, tracking weather patterns
Yes.
to mitigate the effects of climate change. Talk a little about what you found there and how you envision AI becoming a tool for other challenges.
Great. Yeah, this is a very interesting topic. So firstly, I would like to introduce our Penghu weather model. So, Huawei developed our own Penghu model. It's actually a series of large models. So we have one model for NLP, we have another model for computer vision, and also we have a model for weather forecasting, as you mentioned. So it's a series of large models, but they share the similar architecture, and it's the same way we apply it to industries. So for the weather model, so we know that previously, predicting the weather is a very, very challenging task because it involves a lot of parameters, a lot of dimensions, the temperature, wind speed, a lot of large areas, or even global data. So it's huge data, and we also use a lot of computing. It's called usually it's called high performance computing (HPC) methods to do weather
Say that
forecasting.
again. It's called
HPC, high performance computing, because
high performance computing.
yeah, usually it uses, for example, 3,000 servers to do the weather forecasting for the next few days.
Wow.
Yeah, that's a lot of computing, yeah, and also the prediction is not that accurate. That's a traditional method. And now, what we are trying to do is we use large models and then learn from the weather model and then ask it to do the prediction for weather prediction. So what we found that is first, the weather model, or Pangu large model for weather forecasting achieves the state-of-the-art accuracy.
Wow.
It surpasses the traditional methods. And secondly, we can do the weather forecasting on just a single GPU card in a few seconds. It's almost like 10,000 times faster than the traditional methods.
Goodness.
Yeah, so this is what we call AI for scientific computing. This is a very interesting domain. We already applied large models for weather forecasting, for protein structure predictions, for biology, and also for drug discovery. Right? So it's just we combine large models with different disciplines from chemistry, physics, biology, and so on. So I believe this is a new area because previously we also have traditional methods for these areas, but now we're adding in these large models because large models, the parameter is huge. They can learn from the huge data set, and then the performance of the large model may surpass the traditional methods. Yeah, we're still pushing the front lines of this research, but we believe this is very important research. We have already applied our Pangu large models in China's weather forecasting bureau, in Shenzhen, in Hong Kong, and so on. Yeah, they reached the highest accuracy. Yes.
There is really nothing worse than planning your trip.
Exactly.
I'm thinking,
yeah.
okay, great, I'm getting ready for 20-degree weather, and you get there and it's 10 degrees. So you're telling me if I use your model, I'm going to pack the right clothes.
Yeah, exactly.
Okay.
Yes.
Great. Have we got a question from the audience? Otherwise, I'll keep asking. Yes, just here. And give us your name as well.
My name
where
is
you're
Abdul
from.
Majid Al Maktoum. Just maybe it is logistic more than technical question about the manpower. Do you think the age to enter this era of AI should be in 18 years or in university or in the college or the schools? And what about the old people who beyond the 40s? They are suitable to work with this AI era or no? Because this is something new, you know. For old normally in networks, we need engineer.
Okay, so AI and education. Should we be what should we be doing in schools?
The perfect age to enter to this era of AI, or the selection of the peoples, and the type of the people also. If you have answer.
Okay, I will try to answer your question. So I think AI is a relatively old topic, but they have a new breakthrough recently. So this AI, the term of AI already exists for more than like 60 to 60 years. We already exist some existing AI education or lectures already or methods. So I think now the breakthrough is that, for example, large models really pushed the capability or popularity as well to the newest heights. But I think for different people or different group of people, right? So their goal or their purpose of learning AI is quite different. For example, some people they just need to use the latest AI tools, using AI for chatbot to generate images and so on. We just treat it as a piece of software. We just learn how to use it in our daily life, in our work. But for some students, they are interested to do AI-related research, then they need to go maybe deeper. For example, learning from the basic computing science, mathematics, AI courses. So maybe that's in the high school or even in universities, we can learn from that. But for even younger students, I think they can learn the preliminary AI knowledge and then cultivate their interest, and then they may have new ideas. Because AI is still a very quickly developing area, I believe there is always new ideas, new ways of learning and applying AI. This is also very important.
Okay.
Yes.
Thank you. Yes, just here and then just in front and then back there.
Yeah. Thank you.
I'm Piers Say. Are we at a point yet where, not LLMs, but ARs are able to start looking at building and refining in the same way with, say, drug folding, actual other LLMs? So you've got machines iterating repeatedly.
Yes.
I appreciate it's not, we're not talking like AGI level, but is it a deployment that's happening within research?
Yes.
So are we at the point yet where LLMs are able to build other LLMs?
Not necessarily LLMs, but the AIs
or
are
AIs.
used in the same way as you're looking at weather patterns to iterate on models to come up with maybe you should look here or maybe you should look there.
Yes, so this is a very important topic. When we talk about AGI or the future of AI, we mentioned this is a very important feature. I think for now, we are not there yet, but I do see a possibility because, as we know, we have other technology like AI agents, right? So, and also this reinforcement learning, get feedback from the environment, from the other agents as well. So, if we can design this framework so that it can continuously get the feedback and then collect the data, and then I believe this is the next.
We'll be talking about AI agents in just a moment, in fact,
Yes.
with Hassan.
Oh, great.
Where was
Okay.
the next question? Oh, here and then back there.
Yes.
My name is Abdulaziz. I'm a student from University of Prince Sattam bin Abdulaziz.
Great.
And I want to ask, because you tell us before that it's for students to learn AI. I want to ask you, because you tell us for method, depending on your how much money you have or how much capability you have. I want to ask, what's your recommendation of the method, the four method you tell us before? What do you recommend for students to use?
You mean the form methods? Or
Yes, the four method of continuous learning, knowledge editing, and
okay. Yeah, so for students, first of all, I don't directly recommend you to go deep into any of these methods. So I would first recommend you to learn all the foundations for AI, from deep learning to large models, right? Deep learning, neural networks, or transformers. So that is the foundation. And then fine-tuning and other tricks is just on top of that. I think, and also for retrieval augmented generation or RAG, that is more about engineering, right? So you need to design the system, a lot of coding actually. So I would recommend that you focus more on the foundations of large models, and then you will find out that fine-tuning and other techniques, they come very naturally to you. Yeah.
Interesting. The frosting on the cake. Does that answer your question?
yeah, that's my question.
Okay. Just back there.
Hi, my name is Noha. I saw LLMs works really good with the language model and language datasets, but can it work with unsequential data? Do you see any applications out there that's not sequential data?
Okay, you mean, can you give me one example about non-sequential data? You mean discrete?
I don't know,
data?
like images, for example. I saw it, I guess, with videos. It's
I see.
sequential
Okay,
as well.
okay. Yeah, so that's a very technical question. Huh? So normally, for example, when the model is processing language, it's a sequence, right? A, B, C, D is just a sequence. But for image, it's actually a two-dimensional block, right? It's a block of pixels. So it's not a sequence data. But what we can do is that using the same transformer architecture to process images, it's just breaking one image into smaller chunks. And then we reformat that into a very long sequence. We can still use the sequence model to process the non-sequence data, just converting it to the format. Yeah. It's still doable. Transformer is a very powerful architecture to learn and understand these different types of data. Yes.
Great. Just there and then here.
Thank you. My name is Mohammed Al-Malham. Can you talk more about evaluating the evaluation of the answers of the LLMs as an example for the retrieval augmented generation? So let's say I'm giving it billions of data
Yes.
to get the answers. Is there a way or automatic way that you see that for evaluating the answer that's correct, or there should be a human in the loop?
Yeah, so that's a very important question. So first, the output of the large language models, to evaluate the output, we have several metrics. The first one is, of course, the accuracy. For example, the output is correct or not. For example, the date or some history events is just simply right or wrong. So that is one thing, the accuracy. And the second is the relevance. Sometimes you ask a very subjective question, it gives you a very long answer, but it's maybe not relevant to the subject. So that is the relevance. And the third one is, for example, other metric, for example, whether it's concise or whether the word is using is very high-level words or just very simple words. So we have several metrics. So to evaluate the output, we may need to design different method to evaluate. For example, for accuracy, it may be easier because we can easily check it's right or wrong. But for other more subjective metrics, we need a human in the loop. Or even for some facts, we need a human expert team to double check whether the output is accurate. So to answer your question, so I do think there are some ways to automate this evaluation process by designing some mechanisms to check with other systems or databases or get the feedback from other agents, right? So some process may be automatic, but for other or even more subjective metrics, we do need human in the loop to evaluate this. Yeah.
We're going to tread into our next speaker's world a little bit with my follow-up question, but
Yes.
with some of those subjective, more subjective questions, how do you deal with the cultural aspects or the fact that the people who may be training the data have their own biases?
Yeah, that's a very important question. So there's a term called grounding. So that means align the output of the large language models to the values of the society or of the country. So that is very important. So that is still the challenge, I have to admit, still in the industry and in the research as well. So there are several ways. The first is, so first we have to admit there's always bias in the data set. There is no absolutely balanced data. Or even sometimes, some countries, for example, right, so they would have their own political viewpoints.
Right.
They don't want a balanced data set. They want some specific in favor of their own values. So that is the real needs in our society, right? So to do that, we first need to clean the data. So we select the data set according to your criteria. That's the first step for the data set part. The second part is we use other techniques like fine-tuning or other reinforcement learning techniques to continuously train the model so that the output of the models getting closer and closer to the values. So that is the training process. But we have to admit this is not 100% accurate. Sometimes even ChatGPT or other models, the output is still not that balanced, right? They still have some balance. So that is a very important topic. So we are working from the data set part, from the training part, so that to trying our best to align the output to our desired values, align with the values. Yes.
Interesting.
Yes.
Mohammed, do you want to come in on that at all briefly, just but not to give away your speech, but anything you want to just respond on that?
I'll do some of this in my own talk.
Yeah.
But I actually have another question, if you don't mind.
Yeah, please.
I mean, we're talking about updating the knowledge in the LLMs, and you know, you can imagine a user wanting an answer to something that just happened, I don't know, 30 minutes ago.
Okay.
The US debate last night, right?
Which is yet for me to check. So my question is, do you imagine that LLMs at some point will be able to handle these particular types of questions? That's my first part. The second part quickly is, do you see LLMs replacing search engines in the traditional way as we know them?
Okay. Yeah, that is a very interesting question. So I think for very recent, for example, news, right, happened 30 minutes ago. So maybe we would recommend to use the retrieval-based methods. For example, there is already a news article on the internet. I just retrieve it and then answer.
Using normal search, you mean?
Yes, using normal search as the first step, and then using LLM as the second step to generate the direct answer to the users. So that is the retrieval-based methods. And also, in the future, if the cost of fine-tuning or adding in the new content to the model is getting lower and lower, I do see a possibility that it can replace the search engine for many scenarios. Because people is like relatively like the direct answer from larger models. We don't like the search engine. It gives me 100 links, and I need to go through the links again and again and find the final result. LLM's answer is more direct and more concise. I do see this possibility in the future. Yes.
Interesting.
Yeah,
Yeah,
please.
just here in the front.
Assalamu alaikum. My name is Ali Al-Hijab. I would like to ask about the Bango weather forecast model.
Okay.
I have been reading many papers in the research community that's saying that deep learning models are not as good as conventional methods like statistical analysis or XGBoost. So what's the cost from using a multi-model to do weather forecast compared to these models? Like in terms, like probably you are having more accuracy, but what about the computational power to run these and the cost overall?
So can you repeat again? Compare what to the
conventional method like XGBoost or
okay.
statistical methods that are already there.
Okay, so for weather forecasting, right, for the conventional methods, they use a lot of, for example, equations. So, for example, they calculate from the temperature, the wind speed, the previous rain history, right? So it's a lot of computation, a lot of matrix processing. So first, this kind of modeling is not very accurate because the weather is so complicated. So all these equations, they are not enough to model the weather change. So that is the limitation of the traditional methods. The second one is it requires a lot of computation, as we mentioned before. So the advantage compared to the conventional method, right? So the advantage of using large model is that the large model itself, they don't need to directly design equation in the model. Instead, the model will automatically learn from the huge data set. We don't know the specific rules it learned, but the truth is it can do this prediction. It's like sometimes we say it's like a black box, but the truth is it really learned from the huge data set. Traditional method relies on all these equations, but there's always limitations in this equation. But the power of the large model is that it's so large, huge parameters, right? It can really learn from the huge data set. Somehow it just learns these patterns, so it can give you the more accurate prediction. Yeah, so that is the advantage of large models. It automatically learns these rules. Yeah.
We've got one over here. Don't want to forget those folks behind us here. Oh, and here.
Okay.
Okay,
No
we'll come to you
problem. Thank
next.
Hi, Mohammed Al-Dirazi. I just had a quick question. You were talking about how Huawei works on specialized models and specific use cases. So have you guys reached a point where you can definitely say that one approach of updating LLM knowledge to specific use cases is better? For example, let's say I have a finance use case.
Yes.
So is it better for me to go off and use fine-tuning, let's say LoRa or QLoRa, as opposed to training a model from scratch? Or is it a combination of both, where I can take more of a generic finance model and then fine-tune it to my specific use case with, let's say, LoRa, QLoRa, whatever?
Yes. Well, this is a very nice question. So my understanding is like this. If the foundation model already understands the, for example, all the terminology in the domain, for example, finance, you talk about credit card, loans, and so on, right? If the model already understands this, you don't need fine-tuning. You just use IG methods to add in your product manufacturing specifications and so on, and the IG is enough. But sometimes the foundation model is not good enough to understand the knowledge know-how in this specific industry. Then we would recommend you still to use fine-tuning technology to add in some industry-specific data set and fine-tuning, just train it again. Yeah, so yeah, that's our experience. Yeah, thank you so much.
Thank you.
Okay.
And then there was one just over here. And then I think we might need to wrap up.
Hi, my name is Nov. I have a question regarding the knowledge, internal knowledge of LLMs. So LLMs tend to use earlier knowledge, even to answer questions, even when they have a pre-training cutoff data sets.
Yeah.
Is there a way to align language models' internal knowledge to a target time without the need to use RAG models?
I don't know if I understand your question very clearly. So you mean target the knowledge to a specific previous state, or?
Yeah. So the models tends to answer questions when they are trained on the data sets at the time of 2019, even when the data sets have data sets of different times, like recent data sets, 2022.
Okay.
But how to align the internal knowledge of the model from 2019 to 2024?
Yes, so that is what we're discussing about the technologies. For example, we have 4 technologies or even more technologies to keep the knowledge updated. For example, if you ask who's the president of the United States, right? So that changed maybe 4 years or every 8 years, I don't know. So
if you live in the UK, our prime ministers change really quickly, actually.
Yeah, it's more quickly than the US president. So all this knowledge, it keeps updating, right? So you can, I think for now, you can use technology like retrieval-based methods to give you the latest knowledge, or you add in the specific data. You directly ask the question, so what's the president of the United States in the year 2020 or 2024? You add in this specific question. Another way is you just, I don't know if the accuracy of the knowledge editing is good enough. So maybe there's another way is directly edit the model so that it reflects the latest knowledge. Yeah. I think we can try it in different scenarios, honestly. So this is still sometimes is experiments related approach. Yeah.
Fantastic.
Okay.
Thank you very much. Thank you. Well, thank you, Dr. Zhu. Really
you so much.
appreciate it. Fantastic opening
Thank you all.
to our
Thank you so much.
session.
Thank you. Appreciate it.